Hello everyone, and welcome to today's presentation. I'm excited to have you here as we explore a structured guide for students and research scholars. Our focus will be on transforming raw data into meaningful, analyzable insights. The process we'll discuss is essential for making sense of complex information and deriving valuable conclusions. Over the next few slides, we'll walk through the key steps involved in data preparation, helping you turn raw data into powerful tools for research. Let's get started. When we talk about data preparation, the first step is to gather raw data through surveys or other instruments. This is where we collect the initial information that we'll analyze later. Once we have that raw data, the next important step is to clean and organize it. This means editing, coding, classifying, and tabulating the data to make it structured and manageable. At this stage, we analyze the data by applying either statistical or qualitative methods, depending on the nature of our research. The goal is to turn unstructured information into a format that's ready for analysis. This process is crucial because it directly impacts the validity and reliability of our findings. If the data isn't properly prepared, the results could be misleading or inaccurate. So, in essence, data preparation transforms raw, unstructured data into a clean, organized format that allows us to perform meaningful analysis. Remember, this step is fundamental in ensuring our research is solid and credible. When designing your questionnaire, it's important to use clear and unbiased language. This helps ensure that respondents understand the questions and feel comfortable answering honestly. Avoid double-barreled questions, which ask about two things at once, because they can confuse respondents and make it hard to interpret their answers. Keep your questions focused and of appropriate length, neither too long nor too short, so they're easy to answer and don't cause fatigue. When asking questions, respondents should choose from fixed options like, "Are you satisfied?" "Yes" or "No." These are called closed-ended questions, and they make data easier to analyze. Alternatively, open-ended questions let respondents answer freely in their own words, such as, "What do you like most about this service?" These give richer insights, but require more effort to interpret. A questionnaire is a structured tool for collecting primary data. When well-designed, it ensures that responses are consistent and reliable, which is crucial for meaningful analysis. And that's why step 1, the questionnaire itself, is so important. Getting it right sets the foundation for quality data collection and useful results. Now, let's talk about the step of editing in the data collection process. First, we have central editing, which is performed at a central location by a trained editor. This ensures that all responses are held to the same high standards, maintaining consistency across the board. Next, there's field editing, which is done immediately after data collection, often right by the interviewer on site. The goal here is to catch any obvious errors right away, so we don't carry mistakes forward. Finally, it's important to understand that editing overall is a systematic review process. It involves carefully checking the collected data to identify and correct errors, omissions, and inconsistencies before moving on to the next steps. This step is crucial because it helps us ensure the data's accuracy and reliability, which ultimately supports the integrity of the entire research process. Now let's take a look at the slide on coding data. As you can see, we assign numerical values to categorical responses like gender, education, and satisfaction. For example, gender: 1 equals male, 2 equals female. Education: 1 is high school, 2 is college, 3 is graduate, and satisfaction on a scale of 1 to 5. Coding like this allows us to perform quantitative analysis more easily. It simplifies the process of entering data, reduces the chance of errors, and helps standardize responses across different respondents. Specifically, when we code responses, we're essentially converting verbal or categorical answers into numbers or symbols that computers can process more efficiently. This step, which is step 3 in our data preparation, is crucial for accurate, meaningful analysis. So, in summary, coding makes our data more manageable, accurate, and ready for statistical analysis, which ultimately helps us draw reliable insights from our survey results. Now let's look at how we can group numerical data into ranges, which is often very helpful. For example, we might categorize ages into groups like 18 to 25, 26 to 40, or 41 and above. This approach makes the data more manageable and easier to interpret. On the other hand, we can also classify data based on qualitative characteristics, such as gender, occupation, or region. These attributes help us understand the data from different perspectives and can reveal interesting patterns. Proper classification is essential because it reduces the complexity of the data. When we organize data into meaningful categories, it becomes much easier to analyze, tabulate, and even perform statistical tests. Ultimately, classification is about grouping data into categories or classes that make sense for our analysis. This process simplifies our work and helps us uncover insights that might be hidden in raw, unorganized data. Tables are powerful tools because they make patterns immediately visible, which helps us understand the data better. They also support hypothesis testing, allowing us to explore relationships and verify assumptions. Plus, they form the foundation for creating charts and graphs that can communicate insights more visually. Why does this matter? Well, tables can display two or more variables at the same time, revealing interesting connections between them that might not be obvious otherwise. This is especially useful when you're trying to understand complex relationships within your data. When it comes to types of tables, we have the complex or cross-tabulation. This type shows multiple variables simultaneously, giving us a comprehensive view of how different factors interact. It's essential when you want to dig deep into relationships. On the other hand, simple tabulation displays just one variable at a time. It's great for understanding frequency distributions or providing basic summaries of your data, giving a straightforward overview. Finally, let's talk about step 5, tabulation. Essentially, tabulation is about organizing your classified data into rows and columns. This arrangement makes it much easier to compare, interpret, and report your findings. It's a fundamental step that sets the stage for meaningful analysis and clear communication. Now, let's talk about step 6, data cleaning. This is a crucial part of ensuring our analysis is trustworthy. First, we need to standardize formats, fix outliers, and resolve contradictory entries. This helps our data look consistent and reliable. Next, we focus on correcting inconsistencies by identifying and eliminating repeated records that might skew our results. Duplicates can really distort our insights if we don't handle them properly. Then, we move on to handling missing values. Depending on the research context, we might impute missing data, remove incomplete responses, or flag them for further review. The key here is to manage these gaps carefully so they don't compromise our analysis. Overall, data cleaning is the foundation for accurate and meaningful insights. It removes errors, duplicates, and inconsistencies, making sure our data is solid before we draw conclusions. Now, let's talk about what data adjusting really means in this context. Essentially, it's about making sure our data is as accurate and reliable as possible before we dive into analysis. One key aspect is assigning weights to responses. This helps us correct sampling biases or better, reflect the actual population proportions, ensuring our results are representative. Next, we often apply mathematical functions like logarithms or square roots. These transformations help us address skewness in the data or meet the assumptions required for certain statistical techniques. It's a way of normalizing the data so our analyses are more valid. Then we have normalization, which involves scaling variables to a common range, such as 0 to 1. This step prevents variables with high magnitudes from dominating the analysis, allowing for fair comparisons across variables. Overall, data adjusting is about refining our data, making it more accurate, consistent, and suitable for advanced analytical techniques. It's a crucial step that can significantly improve the quality of our insights. Remember, well-prepared data is the foundation of credible and reproducible research. Each step in the data preparation process is crucial, and skipping any stage can lead to flawed findings. So, it's important to ensure quality and analytical readiness from the start. We begin with designing clear, unbiased instruments, like questionnaires, that gather accurate information. Next, it's essential to catch errors early, whether in the field or during central review, to prevent issues down the line. Then, we move to coding, where we assign numerical values to the data, making analysis possible and more straightforward. After that, organizing and structuring the data through classification and tabulation allows us to compare and interpret the results effectively. Finally, cleaning and adjusting the data ensures it's accurate and ready for analysis. Remember, each of these steps builds on the previous one, so skipping any can compromise the entire research process. Prioritizing thoroughness at each stage helps us produce trustworthy, high-quality results that stand up to scrutiny. This slide doesn't contain enough information. That's why we're moving to the next slide.